Welcome students. Today I am going to chapter 2, relation and functions. The remaining questions, our 2.1 exercise. In question number 9. Students, already up to 8, already I explained in the last part. In the Cartesian products related our two sets. So question number 9. Let A and B have the two sets. Number of element A 3 and number of element of B is equal to 2. And x1, y2, z1 are the sum elements for A cross B. And find out set A and set B where x and y and z are not equal. So it's very easy. These are the elements, students, elements of A cross B. It means just I written if x comma 1 belongs to A cross B, same as y comma 2 belongs to A cross B, and same as z comma 1 belongs to A cross B. Students, belong means it is a member. Yes, first x member for A and 1 member for B. Same as y belongs to A, 2 belongs to B, and same as z belongs to A and 1 belongs to B. It means your set A is ready. Students, always you try to this set x, y and z to first elements, and set B is also ready. 1, 2, again 1. So don't write down again 1 because it is your repeated elements not applying in the set for 2 times. Now check. Number of element A is how many? 3. And number of B is how many? 2. So here you are done easily this question number 9. And check here all x, y, z are distinct, then they are applying because distinct element are present in the set. Continue students. Now I am going to question number 10. The Cartesian products of the A cross A elements are given total 9. And some elements given minus 1 comma 0 and 0 comma 1. Find the set A and also remaining elements of A cross A. So it's very easy. First of all, given elements A cross A are given minus 1 comma 0 belongs to A cross A. It means minus 1 belongs to A and 0 belongs to A. Also, students, 0, 1 is belongs to A cross A. So you just saying 0 belongs to A and 1 belongs to A. It means your set A is ready, students. Which are the elements without repetitions? It is 0, 1 and minus 1. Rearrange just minus 1, 0 and 1. These are the 3 elements. You also check number of elements A cross A, which is number of A into number of A. 3 into 3, surely you have to 9 given. Now students, my target is find remaining elements. So how can we define remaining elements? It's very easy. So now I go to A cross A. Minus 1, 0, 1 and minus 1, 0, 1. Only and only, students, I just prepare 2 A cross A elements. So first elements minus 1, minus 1, minus 1, 0 and minus 1, 1. Same as 0 minus 1, 0, 0, 0, 1 and last 1 minus 1. Same as 1, 0 and last 1, 1. And these elements are our A cross A. Now students, my target is minus 1 and 0, 1 given. Minus 1 and 0, it means these are given. 0 and 1, these also given. So other are remaining. Therefore, remaining elements of A cross A. It's very easy. Other all are you mention. Minus 1, minus 1, minus 1, 1, 0 minus 1, 0, 0. This 0, 1 not right. Huh? Now 1 minus 1, 1 0 and lastly 1 1. Check 1 2 3 4 5 6 and 7. These 7 elements, students, in this criteria, other elements of A cross A. And this over. Now students, after that your Cartesian products, I start relation and function legal definitions. Now students, I going to a chapter have new heading after Cartesian products, relations and functions. So in the relations, students, first of all, I just show out the definition of relations. All subset of A cross B is called relation of our A and B for any kind of functions. Just like, for example, if I taking set A 1 2 and B I taking if you 3, so surely you know that what is the A cross B? 1 3 and 2 3. So here all subset formula you know, 2 raised to number of elements, 2 raised to it is 2. It means students 4 subsets are available. It means here 4 relations available. So what the relations? One of the null set, after that 1 3, after that 2 3, and last of the 1 3 with 2 3. These are our 4 relations. Now as students, simple explanations for that definition wise to function with relations. Okay. So students, I going to now any function have A to B. F is indicate functions and A to B is your relations. In this A, students, here you taking it is domain. Yes. And this taking to B, it is codomain. And if you codomain answers, further calculations, you getting that it is a range. Don't worry. One by one, I explain you what is domain, what is codomain, and what is range. In this part, range is always subset of codomain. Don't worry. One by one, I showing to using this drawing. I explain for this relations between A to B. So students, I just draw a simple drawing. You also draw in your notebook. This your first domain part, second your codomain, just like 1 2 3 4, and here answer may be x y z w. These are 1 to x relations. Every member of this domain are uniquely associated with the codomain, then it is a function defined. Again repeat, every element of domain are uniquely associated with the codomain, then function A to B is defined. Okay, again repeat. Every domain members are uniquely associated with the codomains, then the function is defined. It means in this drawing, this relation is exist. 1 to x, 2 to y, 3 to z and 4 to w. One more drawing I draw. Just check out 1, 2, 3 and here x, y, z and w. Just only check here uniquely associated or not domain value. Yes, every member of domain here uniquely associated. So yes, it is also function. Yes, A to B is function. Definition same right above, are uniquely associated. One more drawing I draw. Students, I totally draw 7 types of figure. And then after I again explain you domain and range related or codomains. So figure number 3. Here parts A, parts B, 1, 2, 3, and here X and Y. Check here. This 3 is not uniquely associated with codomain. It means here function A to B is not defined. So no, f of A to B is not a function because this 3 is not uniquely associated with codomain. One more, 4th figure, domain and codomain. And 5th figure, both I combine explain you. Just like here 1, 2, 3, 4 and here X. That types relations given. And here either one. Here X, Y, Z and W. This type relations given. Students, in this criteria 4th and 5th, one is indicate it is a relation exists to A to B. But second is not. So how can you judge this one is a function or this one is a function? Yes, this is a function or not. Just like understanding Narendra Modi sir, our PM. All of you know that his name. But Narendra Modi sir is don't known our name. It means consider this a single person is a Narendra Modi sir. So they cannot relation with us. We all of you known that name. Means here write down yes, f A to B is a function. But here not. It is not a function. Again repeat you. Single person is not a uniquely associated. These are uniquely associated. Basically you just give the again example. Narendra Modi sir is the single persons and these all our Indian people. And here are all our Indian people and this is Narendra Modi sir. Means we all our Indian people known his the name of Narendra Modi sir. But here Narendra Modi sir, if is known over all Indian people? No. So here cannot be name the name for the relations. One more drawing. After that it means students a single number with node associated with the other more numbers. So I just going to 6 figures. Here just like 1, 2, 3. In here X, Y, Z. Here I making 2 arrows. This 2 to Z and 3 to 4. It is uniquely associated? No. According to 5th and this, not a function. And 7th figure, same I just write down. For your more information, here 1, 2. Here uniquely related X. 2 is also X. 3 with Y and 4 with Z. Okay. So these are uniquely associated. Yes, according to 4. Here write down yes, it is uniquely associated. It means for any function, one of the domain with the codomain, both of every relations are uniquely associated, then the function is exist. Yes students, don't worry, I explain you basically example wise. Consider I just taking one of the example for related domain and codomain, and here I define to some range. So for extra example, just like I written for function f for any n tends to n and fx I taking x plus 1. Find out domain and range and codomain. Students, this n is first indicate is your domain, this first. And this is second indicate what? Codomain. Yes, here domain is n. And n you know 1, 2, 3, 4, some numbers. Putting in the fx. Students, if you putting value, it is your domain value. And you getting value after putting, that is your range. Yes, apply here 1. you know that easily. 2, here 3, 4 and here 5 also further exist. But sure, here our range is what? Range is this. They further moving, if you taking further number in domain, means my answer is 2, 3, 4, 5, dot 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 dot, either n minus 1. Because every number present here, only one not present. So I just show out it is n minus 1. So domain is ready n. This is range, and what is the codomain? Codomain is here also n. Yes students, now I go to textbook illustrations related our domain and range functions. So students, continue. Our example 7. Given a 1 to 6 elements and relation given y is equal to x plus 1. Find out implicit relation between the arrow diagrams and their values by to domain and codomain and range. So very easy students, your domain is what? Yes, domain is itself 1, 2, 3, 4, 5, 6 related. I just find out only set A and don't write down domain. It is set A only. And function given a to a. And our fx is students given that in y is equal to x plus 1. Yes. So I slowly our values for a 1, 2, 3, 4, 5, 6 apply inside and find out value of y students. And after that I define our arrow diagrams. So if x1, then y is equal to 1 plus 1. Here apply students. If x is equal to 2, y is equal to 2 plus 1. If x is equal to 3, it is 3 plus 1. Same as if x is equal to 4, it is 4 plus 1. Continue. Till up to students utilize your value is 6. Next, if x is equal to 5, y is equal to 5 plus 1. And last, if x is equal to 6, then y is equal to 6 plus 1. 7, but this 7 is not belongs to your this A. So finally students, your arrow diagram is ready. One of the A and here one of the A, and value apply. So students, applying A value here 1, 2, 3, 4, 5, 6. Here also same as 1, 2, 3, 4, 5, 6. Now check out 1 putting, then you getting 3. I mean 2. So 1 to 2 relation students here. If you taking 2, then 3 getting. So here 2 to 3 relations, 3 to 4 relations, 4 to 5 relation, and 5 to 6 relations. But 6 not applying in that value. So here only relations is ready. So students, your first answer is define relation R from A to A is ready. And that value is easily, students, I mention in this form. So relation R, it is x comma y. You just show out in this form. 1 putting, then 2, 2 then 3, 3 then 4, 4 then 5, and 5 then 6 putting. That this answer ready. Now second answer, it is domain, codomain and range. Students, this domain only I utilize here 1 to 5. So my second answer, domain, is that only 1, 2, 3, 4, 5. And which type of the answer ready? That's your relation, that range. So range is also ready. My range is 2, 3, 4, 5, 6 and codomain. Codomain means students, these are the full values for 1, 2, 3, 4, 5, 6. Note that this always range is a subset of codomain. Every time this statement is students prove for these examples. Now students, I go to next illustrations. It's very easy. Now continue students, our example 8. In this given figure, these two figures are given already. This domain part given and codomain part given. And we find out the relations between P and Q in the set builder form, one of the roster form, and one of the domain and range. So it's very easy students. Check what kind of your relation are. Yes, you putting 9. You getting answer -3 and 3. So here 9 with 3, 9 with -3. Same as if you putting 4, then you getting 2 and -2. And last of the quantify putting, then you getting 5 and also -5. It means students, this R forming is our roster form. And you also check our in set builder form. Yes, in the set builder form, you also applying in the relations x comma y such that check x is 9 but other is y is 3. It means actually here y square equal to x is equal to that. I write down y square. Check y is putting 3 or -3, answer getting 9. Same as 2 or -2 putting, answer getting 4. And here 5 minus 5, answer getting 25. Where x is putting to P set and y is putting to Q. That's are the values for our set builder form. Now last ending also its domain. Students, these are the domain 9, 4, 25. And what is the range? Range is covered to your arrow diagram with 3 minus 3, 5 minus 5 and 2 minus 2. If you arrange this answer according to your increasing and decreasing, so -5, -3, -2 and 2, 3, 5, this value are putted and easily done students. This answer up to our domain, range, set builder form and roster form is a set builder form. And these are our roster form. Now students, I slowly going ahead. Example 9. Let A12 and B34 find the number of the relations from A to B. Students, relation, yes, if you find out relations, then must be you find out first A cross B for these relations, right students? So, first of all here I just find out A cross B elements. How many? 1, 2 cross 3, 4. Yes, it's you known that both of the cross multiplications 1, 3, 1, 4, 2, 3 and 2, 4. How many total elements? Yes, it is 4 elements. So number of A cross B students, here 4. Now I want total number of relations from A to B. Yes, formula is a 2 raised to. Yes, how many? 2 raised to number of A cross B. It means 2 raised to 4. It getting only and only students. It is 16. It's very easy questions. Here not asking the all relations, only asking total number of relations. Now students, I going to our exercise. Next exercise 2.2. Now students, same as I moving ahead. Our exercise 2.2. A given 1 to 14 and defined relation from R is A to A. It means students, your relation to function given you are defined A to A and the R given 3x minus y is equal to 0. So I starting from here for 3x minus y is equal to 0. Definitely you know y is equal to 3x. And now I start putting the value of x from A 1, 2, 3, 4, 5 up to till 14 but covered to A to A. So I start If x1, then what's the y? 3 into 1. Check. It is belongs to your this codomain value. Sometimes they not belong. Huh? So up to belonging, you taking the values. If x is equal to 2, then what is y? 3 into 2. Check. Is also belong to codomain. Yes. If x is equal to 3, then here 3 into 3, it is 9. But that also belongs to, your value is a. And after that, one more I putting, students. Now students, same as if x is equal to, you putting 4. Then what is y? 3 into 4, 12. You also check, it is belongs to your A codomain. Yes. Now I just putting x is equal to further 5. If x is equal to 5, then what is y? 3 into 5, 15. Yes students, these 15 are not present in this A because A is up to 1 to 14. So here write down not belongs to A. Further 6, 7, 8, 9, all up to 14 we cannot put in because it is not present in your codomain. So finally your data is ready here. A to A, I just show out to arrow diagram. A is a 1 to 14. Here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Don't worry, again draw. Totally you write down up to 14. 11, 12, 13 and 14. And these are the one of the codomain. And this side also same as students. Here up to 1 to 14 write down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. But these all are our codomain member. Now check. 1 putting, then you getting answer 3. So 1 to 3 relation exists students. 2 to 6 relations. So here 2 to 6. 3 to 9 relations. 4 to 12 relations. Now 5 to no relations. Because it is not present in this codomain. Therefore students here written not belongs to. Now question read. Write down this domain, codomain in range. So first of all students, I write down in the roster form our question R. After that all value defined. So what is the roster form R? Yes, you putting here 1, getting 3, 2 then 6, 3 then 9, 4 then 12, and after that here define our domain and range. Students, domain means this first value 1, 2, 3, 4 are you just making a relations. So answer is a 1, 2, 3, 4. What is the range? Second value 3, 6, 9 and 12. And codomain, if you asking codomain, then all write down 1, 2, 14. These all are our codomain. But only and only relation when there exists 3, 6, 9 and 12. So here students, this numericals is easily and happily ending. Yes. Now next one, question number 2. Now students, same as going to question number 2. Define a relation R given on the natural number n to relation R. X comma y is a y is equal to x plus 5. It is a linear equation given students where x is a natural number to less than 4. Yes, less than 4 natural number means 1, 2 and 3 and xy belongs to both of the n. So students, I just here define to our function n to n. Yes, only natural number to natural number. But only you taking x is what? It is less than 4. Yes, where x is less than 4 belongs to natural. So which number I taking students? Only 1, 2, 3. Yes students, just question I reading one more time because x is given a natural number less than 4. Not given less than or equal to 4. Only less than 4. And y is any natural number. Now I start. For y, it is x plus 5. Students, x I taking 1, 2, 3 respectively. So if x is equal to 1. So what is y? Yes, it is 6. But check, this answer is present in your codomain. Yes, it is the present in the n. Then you belong the answer, otherwise not. Next, if x is equal to 2, then y is equal to 2 plus 5, which is 7, and also present in the n. And if x is equal to 3, then y is equal to 3 plus 5. It is 8, belongs to n. Now you going to our arrow diagrams. In these arrow diagrams, there are many numbers in this n to n, but I just focus only 1, 2, 3. So here n to n given. Here 1, 2, 3, other number available. Many, infinite. Here also many number available. 1 putting then answer 6. So here 1 to 6. Next 2 putting then 7. So 2 to 7. And 3 putting then 8. So students here 3 to 8. Other number available. Many numbers. Here also available 1, 2, 3, 4, 5. But only and only relation is exist in criteria 1, 2, 3 to 6, 7, 8. So students, you just show out your roster form. In relation R, here given x comma y. So I just putting here students 1 putting then 6, 2 then 7 and 3 then 8. Yes, and easily define our domain. Students, domain you are taking first value. First 1, 2, 3. And what is the range? Yes, range is your 6, 7, 8. So finally, asking your domain range finished. And this numerical is also done. But if you students, this question I just explain you in the extra, just question change only. This numerical done. But I just showing now one of the extra. If you this question asking R is same as here x and here y square. Y is equal to x plus 5 same. Condition also same. These all conditions same. So this answer is changed here students. You putting here R. What the R? 1 putting then answer here 6 square. 2 putting then 7 square. 3 putting then 8 square. And then answer is cover 1 to 36, 2 to 49 and 3 to 64. Sometime given here y square plus y cube. Either x square given, x cube given. So any, the domain is same 1, 2, 3. But range change. In this criteria 1, 2, 3 are domain. And what is the range? Yes, our range is 36, 49 and 64. And that's you're getting the different type of answer. So then sometime here y square given, only y plus 1. So your answer is what? 6 plus 1, 7 plus 1, 8 plus 1. Depend on your questions relations and that you applying your answer students. Okay, now students, up to that our question number 2 in the exercise 2.2 done here. And further explanation students, I explain you in the next part. Bye bye. See you.